Boom. There we go. I thought complement periods meant they added a spot.
Complementary means they added a 90.
Oh, I thought you said complement. I'm sorry. Consecutive pieces are on the same scale. Alternative pieces.
Yeah.
Because like on the inside as like this is alternative.
When we were talking about
I see it.
consecutive
It's very hard to get out.
Yeah, we said like on the same side of a transversal consecutive opposite sides of each transversal. Alright, so as Marissa so eloquently explained, we are starting to talk about parallelograms here. So our definition of a parallelogram is just a quadrilateral with opposite sides parallel. Okay, and then we've got a few properties here. In a parallelogram, we know opposite sides are congruent. Okay, so for example, if I know that PQ is 10, SR is 10. Right? Opposite sides are congruent. Same with these two. If I know PS is 6, QR is 6. We also know that opposite angles are congruent. So opposite angles are the ones that are diagonal from each other. Right? So if R is 100 degrees, that means P is 100 degrees. We also then know that consecutive angles are supplementary. That means angles that are next to each other add to 180. So if R is 100, that means that S would have to be 80. These angles would have to add to 180. Same with Q. Q and R would also be consecutive. So Q would have to be 80. And then those two angles would have to be congruent. Then the final property is actually just kind of a combination of the last two. It's saying if we know we have a parallelogram and one of the angles is a right angle, well, we said opposite angles are congruent, so that means this angle would have to be 90. But then we also know that consecutive angles are supplementary. So 180 minus 90 is also 90. So we end up with all four angles would have to be right angles if we just know one of them is a right angle. Okay. What's up?
That's great.
Amazing. Yes, I know. So let's take a look at a couple of simple practice questions using these ideas here. So in this parallelogram, we want to find the value of each variable using those ideas. So if we start with A, okay, well, 2A is side AB. Well, I know that's going to be equal to the opposite side. So I can say 2A equals 34. Or supplementary. Yeah, but hopefully, yes. So here we would just divide both sides by 2 and get A equals 17. To solve for B, I know opposite angles are congruent. So we could say 8B equals 112. Divide by 8 and 14. Okay. That's pretty much it. Okay. So, questions so far? Alright, so let's take a minute or two here. Practice the ones down on the bottom.
Should we really?
Yes.
First thing I did was I went to the wrong. And this why. No,
Alright, take a look up here at some answers. See how we did. For number 6.
Yeah, that's in the X 9.
Well, so I would have to deal with the left and right sides first.
Yeah, that's what I did.
So if we say 30x equals 150, divide both sides by 30, and 150 divided by 30 is 5. There.
But I did like it. So I kind of missed the whole gist of what we're actually doing. What is the point?
So up at the top, yeah, Marissa explained it very well.
Yes.
Up at the top of your paper lists the properties that we're looking at. So in a parallelogram, opposite sides are congruent, opposite angles are congruent, and consecutive angles add to 180. So consecutive means just the ones that are next to each other.
Shut up.
We're trying to use those properties to solve for each variable here. So what questions do we have here? Number 5? So on number 5 here, I can look at this. I can look at this entire angle here. Okay, I don't need to worry about this diagonal that's drawn. This entire angle would be 60 plus 55, which would be 115. So then I can say, well, consecutive angles add to 180. So I can say 2y plus 115 equals 180. And I can actually do the same thing here. I can say 5x plus 115 will equal 180. And when I solve each of those, subtract 115, we'll get 2y equals 65. Divide by 2, and we get y equals 32.5. Here we'll get 5x equals 65. Divide by 5, and we get x equals 13. 13. What other questions? We aren't having dinner. Yeah, we didn't get very much of what they predicted.
Like, what even happened? He was like looking for all the stairs.
I was out like midnight. It was going pretty hard. I mean, it just wasn't cold enough. It wasn't cold enough for the stairs. I mean, it was cold enough. Everything was
When's
cold
the
snow.
freak first time I was my house?
Alright, flip over to the back then.
I like it.
We have 2 more properties to take a look at. Okay, so the ones on the front are pretty intuitive. Okay, opposite sides are congruent, opposite angles are congruent, which then means consecutive angles add to 180. This one maybe isn't quite as intuitive. Okay, this first property says that if we draw the 2 diagonals just mean we're connecting the 2 non-consecutive pairs of vertices. If we draw those diagonals, then the diagonals bisect each other. What does bisect mean? To cut it in half, right? So what that means is this AP and PC would have the same length, and then DP and PB would have the same length. what this also ends up meaning is that each diagonal cuts the parallelogram into two congruent triangles. Right? So, if I look at, first, if I just look at this line AC, well, that's going to cut this parallelogram into two congruent triangles. Triangle ABC and triangle CBA. Well, that would actually also be true. I could say that these two little triangles would be congruent and these two little triangles. Now, why would that be? Yeah, so if I look, I know that, let me erase these. So I know that opposite sides are the same, right? And then I've got these two triangles sharing a side in the middle. So I can say that side's congruent by the reflexive property. So I could say these two triangles, ACD and CAB, are congruent by side, side, side. Using this idea, we could actually, as Summer just pointed out, also say that the smaller triangles are congruent. I can say this triangle is congruent to this triangle. Again, because we know opposite sides are congruent. And then if I know the diagonals bisect each other, we end up with something like that. So we can say those two smaller triangles are congruent, again, by side, side, side. All right? Questions? All right, so let's take a look at a simple example here. Definition of what? This one's simple. Okay? So, in this one, I'm given the lengths of halves of the diagonal. Right? So, I know that AE is 18, EC is 4y, DE is 6x, and EB is 24. So, if I know that I'm cutting the diagonals in half, I can set each half equal. So, I could say that 4y is equal to 18, and then I could also say that 6x is equal to 24. Okay, each half of the diagonal have to be equal. So divide by 4 here, and we'll get y equals 4.5. Divide by 6 here, and we'll get x equals 4. Are those my final answers?
I mean, maybe.
Yeah. It just says find the value of x and y.
Yeah.
Yep, so those are my final answers. Okay? Questions?
Why could I have done that last night?
Still wasn't cold enough.
Yeah.
Needed it to be a couple degrees colder.
It was almost, I was dying last night. Well, not silence. I was like, whoa. Sideways.
How did that go?
Whoa. I was like, sideways.
Alright, so on these examples down here, we are using the ideas that the diagonals are bisected, but we're also at certain points going to have to use the ideas that these triangles are congruent, okay? Especially when we start getting into finding certain angle measures. Right? So let's take a minute here and see what we can conclude. Actually, let's just try 1, 2, and 3. Okay, and then we'll do one of the next ones together. So you guys try 1, 2, and 3 here, and then we'll take a look at.
forget how that works. That's when the ocean hit. You can also make land. No, I don't want
All right, do we have answers for 1, 2, and 3? What's that? Couldn't figure out 3?
Oh yeah.
It's a bagel feather.
Bagel?
A mango feather. I have heard.
You said bagel feather.
No.
All right, so take a look up here at 1, 2, and 3. Okay, 3 was pretty tricky.
With the add 2x plus.
Well, those 2 angles won't add to 180.
Well, why not?
All 3 angles in a triangle have to add to 180.
How did it,
Number 2. So we know that these 2 sides are the same. Well, I also know that these sides are the same. So if this is 28, this is 28, and this is 28, and this is 28. So we would set 2y equal to 28 and 4x equal to 28. For number 3, this one was tricky. We're told that all 4 sides are the same. Okay? What that tells us about the angles is that each angle here on the inside would have to be the same. Okay? What we talked about in the last chapter, right? If we've got angles opposite congruent sides like this, okay, where all of these triangles we know are the same, these angles would have to be the same. So if these 4 angles, we know 4 angles like that would have to add to 360. Well, if they're all the same, they would each have to be 90 degrees. These would all have to be right angles here for these sides to all be the same. So then we can say, if we look at this triangle here, 60 plus 90 plus 2x equals 180. Right? Then solving this, subtract the 150 over, get 2x equals 30, divide by 2, and we get x equals 15. Okay, then we can use the same logic over here for this triangle. I know that these two triangles would be congruent. So if this angle is 60, this angle here would also be 60. And then I could say 90 plus 60 plus 4y equals 180. Solving that, we would get 7.5. Okay, so that one was a little bit tricky. Questions on that one?
So could we just do 60 plus 2x or minus 180 equals 60 plus 2x?
No, because we have to add in the third angle. Two angles in a triangle don't add to 180. All three angles in a triangle add to 180. Okay. So number 4 actually talks about an idea that we haven't really looked at yet. So we're going to skip number 4. Number 5. We do that one. No, actually 5 is also, we can't talk about that one either. I don't know why they put those ones in there, because those deal with trigonometry, which we haven't talked about yet at all.
Let's do it right now.
We're not going to do trigonometry.
Because 90 and then it would be.
Yeah, so on this one, we can solve for x fairly easily, but then to get y, we would need to use trigonometry, which we haven't talked about yet.
I got 15 right, and I got 6. I didn't get around to 2.
Which is an important part. Okay, but on number 6, we can actually look at number 6 here. We can. Okay, so if we think about everything that we would know here. Okay, well, I know that this whole triangle is a right triangle. If I know this side's 17, well, this side would be 17. And if this little piece here is 4, this little piece here would also be 4. Okay? So what we have here, we have a right triangle, and I'm going to kind of redraw this a little bit here, where we've got this side x, the entire length of this side would be 8, right? 4 plus 4, and then this side is 17. So if I'm looking at this right triangle, how would I solve for a missing piece here? How would I solve for a third side of a right triangle? No, so the sides don't have anything to do with 180.
How to do this square thing on A squared plus B squared.
Yeah, for something like this, we'll have to use the Pythagorean theorem.
Polygonal theorem.
A squared plus B squared equals C squared. Okay, now this is not something that we've really covered yet this year, but I know you guys have looked at this in the past. Okay? So, in a right triangle, the two legs, meaning the sides that make up the right angle, are A and B. So in this case, x and 8 would be my A and B. So I would say x squared plus 8 squared equals, and then the hypotenuse is my C. So to solve for x, say x squared plus 64 equals 289. Subtract 64. Get x squared equals 225. To solve for x, then, we need to take the square root. And the square root of 225 is 15. Okay, so later on, okay, actually in the same chapter where we talk about trigonometry, we'll focus a lot more on the Pythagorean theorem.
Wait, so where did we go with that all?
Later on in the year, yes.
I got it. E squared. E squared. Yeah. A squared.
Real quick, I do want to look at one of these coordinate problems down here. Okay, these are actually pretty straightforward. I'm not lying. Yes. So, these problems down here, okay, where we want to find the intersection of the diagonals. Okay, so we're saying we've got A, B, C, and D. So, here's my parallelogram. However the coordinates are written in the figure are how they go around the figure, right? So, A, B, C, D is how we could draw this figure. So the diagonals would be AC and BD. Okay? I want to find the point where those intersect. Well, if we think about the idea that diagonals bisect each other, all we're finding is the midpoint of one of the diagonals. Okay? Yes. What? So, we actually only need to find one midpoint here, because I know that the midpoint of AC and the midpoint of BD will be exactly the same. How do we find midpoint?
Count. The distance to the half-lift.
Yeah, I mean that's the formula, right? We find the x distance and take half of it. So we're finding x1 plus x2 dividing by 2, y1 plus y2 dividing by 2. We did that at the beginning of the year. So if I want to find the distance from A, or the midpoint from A to C, I'm going to find my 2x coordinates. So those are 3 and 3. Divide that by 2. And then take my 2y coordinates. 6 and negative 2. Divide by 2. So we end up with 6 divided by 2 is 3. 6 plus negative 2 is 4. Divided by 2 is 2. So the coordinates of the intersection of the diagonals is the same as the midpoint of either of the diagonals, would be the point